Have you ever picked up a rock and wondered what it really is? Is it just an ordinary stone, or could it be something that took millions of years to form deep inside the earth? Every rock and mineral around us has a story to tell. From mountains and rivers to buildings and smartphones, minerals play a role in almost everything we use. But how do scientists identify rocks and minerals without complicated machines? The answer is simple. They use physical properties, features that can be observed, touched, and tested. In this video, we will learn how rocks and minerals are identified using physical properties, step by step, just like real geologists do in the field. Before we begin identification, we must understand the difference between rocks and minerals, because these two terms are often confused. A mineral is a naturally occurring, inorganic, solid substance with a definite chemical composition and an orderly internal structure. Examples of minerals include quartz, calcite, feldspar, and halite. A rock, on the other hand, is a natural mixture of one or more minerals. For example, granite is a rock made up of quartz, feldspar, and mica. Simply put, minerals are the building blocks of rocks, and most physical property tests are used to identify minerals rather than entire rocks. The first physical property we usually notice is color. Color describes the visible appearance of a mineral. Some minerals have very distinctive colors, such as sulfur, which is yellow, or malachite, which is green. However, color alone is not always reliable. Many minerals occur in a wide variety of colors due to impurities, weathering, or environmental conditions. Quartz, for example, can be clear, purple, pink, brown, or black, yet it remains the same mineral. That is why geologists use color only as an initial clue, not as a final method of identification. To improve accuracy, geologists observe luster, which describes how light reflects from the surface of a mineral. Luster tells us whether a mineral looks metallic or non-metallic. Minerals with metallic luster shine like metal and often appear opaque, such as galena or pyrite. Non-metallic luster includes several forms such as glassy, dull, pearly, silky, or earthy. Quartz has a glassy luster, while clay has a dull appearance. Luster is very useful because it quickly narrows down possible identities. One of the most important and reliable physical properties is hardness. Hardness refers to how resistant a mineral is to scratching. Scientists use the Mohs hardness scale, which ranges from 1, the softest mineral, to 10, the hardest. A fingernail has a hardness of about 2.5, a copper coin about 3, glass about 5.5, quartz about 7, and diamond ranks at 10. If a mineral scratches glass, it must be harder than 5.5. If it can be scratched by a fingernail, it is very soft. This simple scratch test is widely used because it provides dependable results. Another important physical property is streak. Streak is the color of a mineral's powder, produced by rubbing it against an unglazed ceramic tile. Unlike surface color, streak remains consistent even when the mineral's appearance changes. For example, hematite may look red or silver, but its streak is always reddish-brown. Pyrite looks like gold, but it leaves a greenish-black streak, while real gold always leaves a yellow streak. Streak is especially useful when identifying metallic minerals and separating lookalikes. Next, geologists examine crystal shape and structure. Minerals grow in specific shapes because their atoms are arranged in a particular pattern. Halite commonly forms cubic crystals, quartz forms hexagonal crystals, and calcite forms rhombohedral shapes. Even when crystals are broken, fragments often show clues about their original structure. Crystal shape provides strong evidence, especially when combined with other properties. How a mineral breaks is also a key identification feature. This brings us to cleavage. Cleavage occurs when a mineral breaks along smooth, flat surfaces due to weak bonds in specific directions. Mica splits easily into thin sheets, halite breaks into cube-shaped pieces, and feldspar has cleavage in two directions. These breaks are smooth and predictable. If a mineral does not break along flat surfaces, it shows fracture. Fracture is irregular and unpredictable. Quartz is a classic example, breaking with a curved, shell-like surface called conchoidal fracture. Other fracture types include uneven, fibrous, or splintery. Distinguishing between cleavage and fracture is one of the most important skills in mineral identification. Another useful property is density, which refers to how heavy a mineral feels compared to its size. Some minerals feel unusually heavy because they contain dense elements like lead or iron. Galena, a lead ore, feels much heavier than an ordinary rock of the same size. Geologists often use a simple heft test to judge density before making exact measurements. Some minerals have special physical properties that make identification much easier. Magnetite is magnetic. Calcite reacts with weak acid and produces bubbles. Fluorite glows under ultraviolet light, and sulfur has a strong smell similar to rotten eggs. These unique properties can confirm a mineral's identity almost instantly. In real practice, geologists never rely on a single physical property. They combine many observations to reach an accurate conclusion. For example, if a mineral is clear or colored, has a glassy luster, scratches glass, shows no cleavage, and breaks with a curved fracture, it can be confidently identified as quartz. Using multiple physical properties together ensures accurate and reliable identification. Identifying rocks and minerals is not just important for science classes. It is essential for mining, construction, jewelry making, environmental studies, technology, and understanding Earth's history. Every building, vehicle, and electronic device depends on minerals extracted from the Earth. To summarize, rocks and minerals are identified using physical properties such as color, luster, hardness, streak, crystal shape, cleavage, fracture, density, and special characteristics. The key to accurate identification is careful observation and using several properties at the same time. The Earth has been forming rocks and minerals for billions of years. When we learn to identify them, we learn to read the history of our planet written in stone. If you found this video helpful, don't forget to like, subscribe, and share. More educational and discovery-based videos are coming soon.